This is the part 3 video of the White Belt Kata in Java. In this video, we're going to conclude the White Belt Kata. We're going to do steps 7 through 10. So we're going to make the test pass, we're going to refactor, we're going to make the app run, and then we're going to refactor again. So we're picking right up where we left off in part 2 video. We've got our test file, we've got our calculator file, everything's ready to go. So we need to make the test pass. So to make sure we know that it passes, the first thing we need to do is run the tests. So we'll hit on this beaker icon over here for testing. I will hit this run tests, it's the play all. We'll go and allow that. Let it run. Let's try that again. All right, so prime numbers doesn't have any tests because I commented out. The console app does, and if we look down, it is indeed failing. I'm going to double click on that. And we'll see unimplemented method. Well, this is the unimplemented method exception we have right here. So that makes sense. It is definitely failing, and that's what we want. So we're in good shape. It does run and it does fail. So we need to make this pass. At this point, we're going to be inside this prime number calculator class. So I'm going to expand this up a little bit, give us some more space, enlarge the text a little bit so we can see what's going on. Start off by deleting the, basically deleting the exception that was there. And what we're going to do is we're going to implement this method. Now, this method basically follows a pretty standard pattern. We need some way to hold on to the list of integers as we find them. So as we find them, we'll hold on to the prime numbers. We're going to loop over the numbers all the way up to max prime number. For each one, we're going to ask, is it prime? And if it is, we add it to the list. And then at the end, we return it. So this first part is pretty straightforward. We're going to create some list that we're going to hold on to it. So I'll do a list of integer. And we'll say this prime numbers found. You could also just call it prime numbers. You could call it primes, totally up to you. And I'm going to create a new array list. And now we're going to need to do a couple of imports. We need to import java.util.list. We're also going to need to import java.util.ArrayList. So we're going to need both of those types in order to run through. You can type these by hand, or what I did is I clicked on the thing that was red, control period, that pulls up the list, and then you just add the import. So there's our array list. Now that we have those, like I said, we're going to iterate over the numbers. And I'm going to do this as a simple for loop. So we'll say for int. We're going to start at 2. So 0 is not prime, 1 is not prime. So we don't need to check for either of those. You could start at 0, you could start at 1 if you wanted to, but those aren't prime, so it's not going to do anything. So I'm going to say we're going to start at 2, and we need to give this a variable name. I could call it I, but I want something more descriptive. Each one of these is basically a possible prime number. So I'm going to call it possible prime number starting at 2. Possible prime number, and this is going to be less than or equal to max prime number. And then finally, possible prime number plus plus, add 1 each time through the loop. There's our loop. Let me zoom out just a little bit so you can see the whole thing. So int possible prime number is 2, less than or equal to prime number plus plus, we're set. For each one of these, we're going to test that number. So we're going to call some method that does not yet exist. We're going to say if is prime, possible prime number. If it is, then we're going to add to prime numbers found. So we'll say prime numbers found, add possible prime number. Because now it's no longer possible, it is a prime number. Once we conclude the loop, we need to return the prime numbers found. Now the problem we're going to run into here is that this is a list of integer and we need an int array. So we need to stream these out. So we'll say stream.map all right, sorry about the IntelliSense. It's really messing everything up. I need to shrink this down a little bit. Bear with me 1 second. Okay, so integer value of. No. All right, I have to remember how to do this. So for each integer, this is going to be an integer object map I dot. I think I can just I. All right, I do not remember how to do this. We need to map to int. There we go. I got to call the right one. Map to int. To int function. I thought it was just value of. To array. It is. Okay. The red was throwing me off. So yeah, prime numbers, we're going to stream that out. We're going to call map to int. I'm going to give it the value of method, and then we're going to call that to array. That's our conversion. been a while since I've done this. I apologize for the delays there. So now we have everything up and running. We do have a couple things going on. So it's saying, hey, you've got something here. What we're doing is we're constructing an empty list with an initial capacity of 10. It's a raw type. References to generic should be parameterized. So it's saying, do you want to basically add that in? So let's go ahead and do that. That'll just make it a little stronger typed. That gets rid of the warning. Now for the error, we need to create this method. So this is the next part of the algorithm. So this is the first part of the algorithm. Everything looks good there. Now we need to create our isPrime. So again, once again, I'm going to do a control period and I'm going to let it generate my isPrime method. So it generates that right down below. So it's going to take possible prime number. I'm going to rename that to just number. I don't need to know that it's a possible prime number, but it will return Boolean. What we're going to do here is we're going to loop over the numbers below number, not including 1 and not including itself, because of course it's divisible by 1 in itself. And we're going to test each one to see if it's evenly divisible. So we'll do another loop. So for int, and this will be, I'm going to call this factor. So for each factor below it. So factor starting at 2, factor less than number. We don't want it to equal number. We want to stop below that. Factor plus plus. And now I can zoom in a little bit again. So for each one of these, we're going to do our test. Our test is basically saying if the number mod factor, which is going to give us a remainder, equals 0, then it's evenly divisible. We return false. Otherwise, if we make it through the entire loop, we return true. And that's effectively it. That's all we really need to do here. Now, there are a couple of optimizations we can do for performance. I'm not going to do those as a part of this video. This is all we really need. So I'll zoom back out a little bit so we can see everything. That looks pretty good. Let's go ahead and run our tests. Let's run everything. And we do have a passing. So we're looking pretty good. Everything's looking fine. Let's go back to our README file now. So we have now made the test pass. Now we want to refactor. Refactor is a fancy word for saying change the way the code looks without changing the behavior. In other words, we can move things around, rename things, but we don't want this pass to go away. This is why we do refactoring after we have a passing test. So let's look and see what we've got. There are a couple things that I could probably do here. Let me add a methods. So these are all methods. These are alphabetized, but another thing I want to do, Java wants method names lowercase. So I'm going to rename isPrime to a lower I, make sure that all works. I think the rest of this looks pretty good. Let's head to our tests. Everything looks pretty good there. I think we're in good shape. I don't think I see any more refactors I want to do. I'm going to run the test again, make sure it still passes, and it does. All right, so we're now done with our refactor step. During the exam, I do expect you to call out that you're doing refactor. Even if you don't do any refactors, if you don't change any of the code, you need to let me know that this is on the refactor step. And you can just say, I don't have any changes I want to make, or I'm not going to do any refactoring. Step 9, we need to make the app run. Making the app run is basically making the console application work. So I'm going to go to the app.java, which is the entry point for a Java app. Again, I'm going to Control-A, Control-K-F, just to reformat. I'm going to get rid of these comments. And once again, Control-Shift-P, convert indentation to tabs, just to clean everything up the way I personally like the code. Now that we've got that, what I can do is I can run this. And there's a few different ways that you can run it. But I'm going to just basically say run and debug. All right, so we got hello world, which is not what we want. We want it to spit out the numbers up to 100. So this is not what we want. We can go ahead and get rid of that line. What we do want, let's head back to the test, because we're going to pull from the test. We're going to copy these two lines here. This is the use case. This is how the application is supposed to actually work. So I'm going to copy these in and paste them into my main method. Now I'm going to do a couple of renames. First off, we're going to say primes instead of actual primes. And secondly, instead of 19, I'm going to go all the way to 100. So these are the primes in 100. Now I want to print these primes out to the screen. It won't work if I simply go to system.out.println primes. If I do this, I'm not going to get what I want. So let's look and see what happens. It gives us this weird, ugly thing, which is basically a Java reference number. So primes will not output the prime numbers that I want. What I have to do is I have to loop over those. So I'll say for var prime colon primes. So then we're going to for each over these, and then we're going to basically list those out. So let's do something real fast. I'm going to say system.out.println prime numbers up to 100. So there's a line, and now we're just going to print each one of these. I need a semicolon. System.out.println prime. So now I think I've outputted those. Let's run it again. Go up to that. Prime numbers up to 100 are. Those look right to me. All right, so we have now concluded step 9. So there's the README, step 9. Step 10, one more refactor. Again, I don't really have any refactors I want to do here, but you do need to acknowledge that we're doing a refactor step. I think this all looks pretty good. I was cleaning things up as I went. So we've now concluded that step. That is the prime, or the white belt kata using the prime number problem in Java. I do want to go one more thing. I previously talked about the edge case. So if I go back in 19, the reason this edge case is important is, let's say I do 20 instead of 19. I do expect it to include 19, and then I'm going to run this. Oh, not run. I want to do the test. I'd expect this to pass. Everything's looking fine there. Now I'm going to change the logic here a little bit, and I'm going to introduce a bug. So inside my loop here, I'm going to change this to less than instead of less than or equal to. This is actually a logic problem, but if I run the test, it's going to pass. The reason is I didn't test the actual boundary condition, so I didn't include the number. It's looking less than 20. Well, 19 is less than 20, so we're fine. This is why if I choose 19 as the edge case, I am going to find this bug that I introduced. So now when I run it, I do indeed get an error, and it's basically saying I expected there to be 8 prime numbers. There were actually 7. So now I know that I have a problem. I can go back, find my error, introduce the correction, which is less than or equal to rather than less than, rerun my test, and I'm good. So I just wanted to walk through that really fast, make sure that was clear. That's why we test the boundary condition. I hope this was helpful. Good luck on the exam.